Dropbox, IFY, DIFC workbook, physics, waves, stationary waves. Right, we have to do some examples, don't we? Can we see okay? Is that okay, guys? No, that's a little too. How's that? Is that?
Yes.
It'll do. It'll have to do, I'm afraid.
Check out the lights.
Yeah, go. Could you get the lights, please? Okay. So, where's our first example? We did that, we did that, we did that. We did that.
And correct.
Yeah, and correction. We did that. So we have to do some examples now. Okay, so I just have two. Yeah, two small examples. This one here, I think you can do this one. The boy has a rope. It's 2 meters long, and one end is tied to the wall, so it's kind of like this, you know. And he makes a stationary wave, first harmonic. My question is, what's the wavelength? So maybe you want to draw it, and then you can tell me the answer. Should take you just a few seconds if you can draw it. Got an answer?
1 meter.
No.
0.5 meter.
7.5.
No.
Oh.
No.
Wavelength is lambda.
Yes.
Lambda equals 2D.
No.
2D and
Yes.
what's the question? Oh, lambda. For 8 meter.
No.
1?
4?
Yes. 4.
2D.
Yeah.
What is D between node and antinode?
No, between node and node.
Is this one?
No, it's this one.
This one?
Node and node.
Not this?
Yeah, it's that one.
No,
So,
not this.
no,
Why?
it's a string,
That's
a rope.
Just
Yeah,
one, two
yeah,
node
yeah.
and
Yeah. So, if that's 2 meters, then it means the wavelength is 4 meters. Yeah? Is that okay?
Yeah.
So
Is it?
lambda equal 2D is only work on the rope? It's
No.
not on the pipe
No,
also?
no, it works here. The D here is 2 meters, node to node, or antinode to antinode. The lambda is also 2D. The D is 2 here. Yeah? Is this okay, Gal? Are you sure?
Yeah, I just didn't have this on the notebook.
Okay. Stationary wave is formed in a pipe which is closed at one end and open at the other end. The wave formed is a first harmonic and the frequency is 500. What is the speed of sound? So I'll just draw the system. You have a pipe. It's open here. It's closed here. Okay. You make a wave here of 500 hertz. And this is 17 centimeters. And you make the first harmonic, the fundamental. What are you asking her?
How to calculate the speed?
That's the formula.
Omega.
B equals
Omega.
lambda F. Ah, you do. You have to use this formula.
Yeah, so the length,
Well, you'll have to draw it. You need to draw the fundamental in here.
So is this
I can see.
it's
Yes.
close open?
Yeah. Yeah.
So I think it's 40
For L.
for L.
Yeah.
So 17 for
68.
V,
No, the length.
the wavelength.
The
Yes.
16
Yes.
and
And we need the meters or.
Oh, it must be meters. Yeah.
And 500 hertz.
500 hertz, yeah.
13,700.
For V?
Oh,
2.1.
Too big.
2.125.
For V? No.
oh,
It's
it's
in
same.
meter.
3.4
I mean,
meters
okay.
per second.
No. The
Three,
speed of sound is 3
300.
meters per second.
370.
Oh,
What?
Yes.
three,
Yeah.
70.
So, oh come on, look, V equals lambda F.
Yeah.
Lambda we think will be 4L.
Oh,
Yeah.
4 over from.
Is 0.68.
Times 500.
Yeah, 500 is
68 times 5.
3.
340.
Yeah, 340.
Oh, four.
Oh.
Huh? 4?
Yeah.
It's 4.
4 it is, yeah.
Oh, yes.
Yeah?
Yeah, I just forget the 2 0.
Yeah. Okay. Okay. I want to do another one here, but a little bit harder. Yeah. Can I scroll down? Yeah. Okay. 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 So what you do, again, same as before, that's 17 centimeters and that's 500 hertz. Okay? And then what we do yeah, okay. Then you make it 1000 hertz, and this is the first harmonic? No. I can't. I need to have a look at the workbook. I need to use some real numbers. I can just borrow that for a moment. Okay. Right, okay, so first pipe we have 1100 hertz and we have the third harmonic. And then for the next one it's the same pipe, 1800 hertz. And for this one we have the fifth harmonic. Good. Okay. And there's two ways that, remember last time we were talking about end correction. Remember we said that? So what's going to happen here, the third harmonic, let's try, no, I'll let you first try to draw this. Draw the third and the fifth in here. Yeah. Good man, Ben. Yes, okay, good.
Draw the
Third and fifth. Yeah? Yeah. So, I think you got it, Ben. So, yeah, that's the third one.
Yeah.
And then the fifth one,
Five.
yeah.
Yeah.
There we go. That's the third and the fifth one. Okay. Now, this guy here is Al. Oh, we said Al. What do we say it was? 7. Oh, sorry, I need the book. I don't know what the Al is, or maybe I didn't tell you. The Al is. I don't tell you the Al. That's funny. Maybe you don't need to know the Al.
You can keep them.
Yeah, just a sec. I don't tell you the Al. I should tell you something. I shall tell you. Okay. I don't tell you the Al. Let's see if we can do it without the Al. If we need the Al, I'll give you a number, okay? But we'll see if we can't do it. Maybe I should tell you something else. We'll see. So here, this is Al and this is Al. So for the first picture, what's the wavelength? As Al.
4/3 L.
Good man. 4/3 Al. And for the second one, what's the wavelength?
4/5 L.
4/5 L. Good job. Now, we can use the formula V equals lambda F. Yes? So, I can change this if I want to. I need to get in the F. So I'll say F is V, F lambda is V/F. So here I can change this into V/F equals 4/3 L and V/F equals 4/5 L. Now of course these F's are different for each, okay? So I'll write F1 and F2. Okay. But the L's are the same,
Yeah.
and what do we think? Is the V the same or not?
No.
The V the same or different? What do we think? Yeah? Anyone else? I think so, yes. The V is the same. Why?
So one hertz is one
No,
sound.
no. The V is the same because they're both sound waves. They're both sound in air. The V is the same. The F doesn't change the speed of the sound, it just changes the pitch. You remember when we were listening to the TV? The F just changes the pitch. Doesn't make it go faster or slower. Okay? Is that okay? Now, okay, I do need to tell you, I haven't given you enough information. I have to tell you something. So I guess I will tell you the L, or maybe I'll tell you the V. I'll tell you the V. So I'll also tell you that the V is 340. Okay, so you know this. You know this, it's given.
It's constant.
Yeah, for this question. Okay, so here we have 340 over 1100 equals 4 over 3L. And here, what do we have? 340 over 1800 equals 4 over 5L. Yeah? But there's a small problem. The small problem is, remember we said sometimes the wave sticks a little bit out, and sometimes it sticks a little bit out here. So, what do we think? This V equals 4 over 3L. We need to fix this a little bit. Is it too big or is it too small?
Too small.
Small.
What do we think?
Too small.
Too small, is it?
Yes.
Has to be.
So, if it's too small, how can we fix that?
Okay.
We need to add a little extra correction to it. So, instead of being L, it should have been perhaps L plus delta L. So I should put in here L plus delta L. And likewise here, it should have been L plus delta L. There should have been a little bit extra. So how does that change things here? It changes it a little bit, doesn't it? L plus delta L. L plus delta L. What have we got here? We have two equations with two unknowns. Yeah.
Excuse me.
Can somebody... I just need somebody to bring the 3 up here and the 4 down.
Yeah.
And bring the 5 up here and the 4 down.
Well, I think
Oh, yeah, mistake, sorry. Yes?
what is the 4 over 3L?
Yeah, you're sorry, I made a mistake. I have to go back. The 4 over 3L? That's the, how did we get the 4 over 3?
Oh yeah.
Yeah, well, somewhere gave us the 4 over 3. So the wavelength, if this L is 3/4 of the wave, so one full wave, divide by 3 and then multiply by 4 gives me the full length. No?
Because the length is 3 over 4 waves, so the whole wavelength is 4 over 3. We just
Yeah, I think I should have just written it like this, yeah? That was my mistake. I shouldn't have put the brackets. So it should have just been like that. Yeah.
Sorry, I have a question. For the 4 over 3L.
Yeah.
You added delta Y, delta L. But for the 4 over 5L, must you add delta Y? Because
Yeah.
I thought the...
No, it's the same for both. It's the same delta L for both. It's the same little error for both. Yeah.
every pipe, the delta L is the same.
Yeah.
Everyone.
Yeah, it is, believe it or not, yeah. Because it's strange, but the delta L depends on the diameter of the pipe.
Oh.
It has nothing to do with the wave. So, yeah, it's strange. The delta L is the same for every pipe. It's strange.
Even the pipe is short or tall, it's still the same.
No. If it's a different pipe, it's a different delta L. But if you have two pipes which are the same, it's the same delta L. Yeah? So, okay. Sorry, we were trying to clean this up a little bit. I want to know what the delta L is. That's what I'm trying to calculate. So what I'll do is I'll bring the 3, I'll multiply by 3 and divide by 4. So 3 times 340 over 4 times 1100, that's equal to L plus 3 over 4 delta L. And then 5 times 340 over 4 times 1800, that's equal to L plus 5 over 4 delta L. Can somebody give me those two numbers, this and
Is
this?
the arrow same?
Hmm?
The two arrows same?
Oh yeah, it's the same pipe.
Ah.
Yeah.
Okay. Okay.
First one is
Yes.
0.2312.
2318, okay. Equals L plus 3/4 delta L. And then the second one, please.
Is 0.2361.
2361. That's equal to L plus 5/4 delta L. Okay, so all I have to do is right minus left. 5/4 minus 3/4. Oh, yeah, 5/4 minus 3/4, yeah? That's a half. So you have a half delta L equals 0.2361 minus 0.2318 43, and then you must multiply by 2. So you get the delta L is equal to 86, thank you, millimeters. That's the error, the end correction. This is quite hard. Sometimes they ask you this question in the exam, sometimes they don't. Sometimes it's a question like this, which is hard, and sometimes it's a question like this, which is easy. You know, so I'd say 80% of the time it's this,
20%.
but then I'm sorry to say 20% of the time it's this. It's a harder example. Could you write this example down carefully?
What's the answer? Yeah.
Oh,
It's
86. It's okay, or is it hard.
Okay.
Now. So good job, Summer, on this step here. Because this step always confuses me. I always forget, do I write it like this? Or do I write it like this? I always forget this. So you're right, it needs to be like this.
In the first time, I think maybe the delta L is one part of the whole length. Maybe.
Yeah, I think it might be a little less confusing if instead I write it like this, forward 3L plus error. You know what I mean?
Yeah.
So you can say like this, the wavelength is equal to 4 over 3L plus error. And this error is the same for the pipe. So this doesn't care. This doesn't care about this number.
Okay.
It doesn't care if it's third or fifth harmonic.
So
It's the same.
The error is not one part of the whole length. The whole
No,
length
it's
of the
fixed.
length. Okay.
It's fixed. So it's like the error is always, like 86 millimeters. It doesn't matter if it's the third or the fifth harmonic or the 10th harmonic. It doesn't matter. It's a constant. Yeah? Yeah. You have a word for this. I don't know if you did it in chemistry. Have you done these words in chemistry? Systematic error? No, okay, alright. Not to worry. Now, did you get your homework finished? I have the answers for you if you want to check.
What?
I can give you the answers if you want to check the answers. Did you do any work somewhere is my question.
Well, what more?
Ben, we did the answers to 107, didn't we? So I have to give you the answers for 109. Yeah? Did you try them?
No.
Huh? You didn't do 109?
Yeah,
Did you do 111?
A little.
Oh, what's going on? How come? Happy holiday indeed. I'm not going to give you the answers until you try them. And then of course you have 113, which is today. What answer did we get? 86 millimeters. Was it?
Strong?
I must have wrote my answer wrong here. Yeah, no, that looks right. I think it's me. I just wrote it wrong. Okay. What to do now? Oh yeah, sorry. On page 113, you can. I forgot. Right on the top of 113, you can assume the V is 340 meters per second for all questions. I didn't write that on the top. So for all the questions, well, not all the questions, I suppose. Questions 1 to 5. All questions 1 to 5. Harp. You know what harp is. You got any money?
My mind.
Coin. Look,
Well,
that's a harp.
no. Okay.
You know this?
Yeah, I know. Tuning,
English.
uh,
This is a harp.
Where's the word?
the first one.
You know this word, Ben? Harp.
No.
You know this. You know this. Show Ben.
Shoot.
Up. Show Ben.
Is it a star?
It's not a star.
What's
That's a harp.
oh.
You have these in China?
It's like the guitar.
Yeah.
Oh,
Okay.
it's an instrument.
Yeah.
Okay. I thought it was like horn or something.
What I'll do in a few minutes, we'll do maths next because I feel like we've done more physics than maths so far, right? Like we've only done how many maths lessons? Probably only 4.
Yeah, feel.
Not many. We did product, quotient, chain, implicit,
And
Did substitution.
So you didn't follow the order.
Yeah,
We are the same in science. Order the same.
yeah. Product, quotient, chain, implicit. Oh no, I guess we did more. We did 1, 2, 3, 4, 5, 6, and for physics. Oh, we did more physics. We did more maths than physics.
No, we did. I think this week we have 3 days holiday. They didn't have maths at all.
Yeah, but we did 6 hours of physics so far. We did 1, 2, 3, 4, 5, 5. And in maths we did 1, 2, 3, 4, 5, 6. So they're balanced. We've done 6 hours of maths and 6 hours of physics. So what do we want to do? Maths or physics?
After.
You don't care?
Okay. Anything's the same.
I think we should do maths because you haven't done much physics homework.
Yeah.
And I don't want to do more physics until you do some homework. So we'll do some maths. Okay? Don't worry. If you want, you can take a picture of the questions from my book. I can give you my book. Who has their maths book? Does anyone? None of you? Good. Okay. Yeah, so... No, I have mine, so I'll give it to you in a minute then, okay?
I don't know which page.
It's called... Go to the front. Go to the front. The front. And look for a chapter called Integration 2. Next page, maybe. Oh, no, that page, yeah. Integration 2? By parts?
High part.
Yeah.
1, 2,